Hello viewers, welcome back to Strictly Coding. If I ask you to display the text Hello World onto the screen, probably you will write a main function in C++ or in Java within a minute or less. But have we ever thought of how these main functions are composed? Are they different in these two programming languages? The dealing of displaying the text onto the screen are the same or not? We are going to explore that in today's video, coming right up. Hey, this is Subrata Kumar Dey. I am a university teacher teaching computer science courses over 1.5 decades. If you are a coding enthusiast or new to this channel, consider subscribing. Also press the notification bell so that you don't miss any future update. So let's begin. To explore the differences or similarities, whatever it is, between the main functions in Java and C++, I have written the equivalent main function to print the text Hello World side by side. So as you can see on the left, I have written the main function for Java, which will print Hello World, and also I have written the same thing for C++ at the right. Now, as you can see, I have listed a few differences which at the beginning may appear as differences from bird's eye view, and some of they are actually differs in two languages, but some of them are visual illusion for us to perceive them as difference, but internally they apply the same mechanism. So we'll understand when we explore one by one. Now in Java, there is nothing global technically, but anyway we can represent something globally using static, but technically nothing global in Java. So therefore, if we want to declare a variable or define a function, the variables has to be a field of some class, and the functions has to be methods of some class. So therefore, even the main in Java is a method of some class. So in our example, the main method is a member function of the class called main class. Okay, so that's a difference. But in C++, the main is a global function. So the number one holds true. Okay, it's a method in Java. It's a global function in C++. Now, why even the main method has to be a method? Because Java is a purely object-oriented programming language. So we cannot actually do anything without being part of a class. Okay, so that is why anything we declare or define as function has to be a member of some class. On the other hand, C++ supports object-oriented programming, so you can define classes in C++, but it's not mandatory. Like in this case, we are trying to print hello world, so we can very well write a C++ program without having any class, and that is why it is allowed. It allows us to have global functions or even define global variables, okay, or objects. Okay, the second difference is that I have listed according to my code is the return type. So the main in Java return type is void, and the main in C++ has return type integer. Sometimes we may feel that this is a difference because some IDE will not allow us to compile the C++ program if the return type is not integer. For example, to demonstrate here, I'm using the code blocks ID for C++. Okay, so let's say I have written the main function where the return type is void, so I don't need that return statement. And if I try to build it, it gives me an error. Okay, and it tells that main must return an integer. But again, that might prompt us to think that the main functions in Java and C++ has different return types, but that's not true. Here the requirement of int main is a requirement set by the code blocks IDE. Okay, suppose if you use a different IDE, for example Microsoft Visual Studio, then you can very well have the void main. Okay, so in both cases, technically as far as programming language is concerned, both C++ and Java can have void return type. Okay, so in this case the void doesn't work for code blocks because it's the requirement set by IDE. Okay, why code blocks wants C++ to return an integer back to the operating system, that's a different discussion. That's beyond the scope of this video. So probably in some I can dedicate a video for that. Okay, so let's continue. So number 2 is not necessarily is true. Okay, so both of them can have return type void. Okay, now let's explore the third differences that may appear as a difference. So in Java main we have parameter, in this case a string array, but in C++ main we don't have any parameter. Now again that's the perceived difference, because most cases we don't provide parameter to main. Normally we don't call main from our program. We know if a function takes parameter, then the caller function need to specify the parameter while calling the called function. Now we don't call main typically, even though we can call main from our main. In that case it will be recursion, and almost it doesn't have any implications, or it's not a requirement in most cases. So that's why we normally don't provide argument or parameter to main in C++. But if we want, we can actually. Now how can we provide parameter to main in C++? Well, there are two ways. We can actually set the parameters, fixed parameter, to the IDE settings, in our case code block settings, or any IDE settings, or we can go to the command line, which was the case in back then when we used to use DOS operating system. We used to use everything from this command line using the commands. So from here actually we can type the executable name of our application, and with space we can provide the parameters or the text input, and that will go to the main function as parameters. Okay, so that's possible. So let me try to show you. So in that case, the no parameter actually is not a difference between these two mains. Okay, both mains can have parameter. In fact, in Java main we must provide the parameter, otherwise it will not compile. But in C++ main it is optional. Okay, but it's not a real difference, because in C++ we can also provide parameter to main function. So let me try to show you. Now I have created another version of main. Now if you see here, whenever we provide parameter to the main from command line, now you see we have to type whatever we want to provide from keyboard, and whatever we type from keyboard are text, okay, ASCII characters. So therefore and space is a natural separator, so therefore we can actually provide the input separated by space, as many as we want, and they will go as text. Okay, so number of text, bunch of text. So it can be array of strings to represent those text, which is the case in Java, or it can be array of character pointer in C++, like this is an array of character pointer, or even we can have pointer to pointer, like double star pointer. Okay, so either way we can either use an array of character pointer, or we can use a double star pointer. Now in that case, in either case they can represent the collection of text, okay, separated by space. Okay, and the first parameter is the argument counter, that is the de facto variable names, but as you know, you can give any name, but that's the de facto names, the most widely uttered name for the number of arguments. So argument counter, and this is argument vector, but you can give any array. Okay, so now if I want to demonstrate you the command line argument, so let me comment this main and uncomment the command line version. There you will see that the main has two parameter. Okay, the first parameter is an integer which tells the how many arguments or parameter will come, and the second one is the array of character pointer. That means it can represent the number of text in that array. Okay, because character pointer itself can represent a text, okay, like hello or world or 12.5, whatever it is, everything will come as text, because whatever we type from command line, this is command line CMD, we have to type in the keyboard, and every key we press on command line is ASCII character, so we need to store them as text. But however, we may wish to provide some numeric value, but they also will go as text, and in that case we have to convert them from ASCII to integer or ASCII to float or ASCII to double and treat them as a numeric value. But as parameter it will go as a string. Okay, so the name of the program is command line argument.cpp. so if I build this, so I have the exe command line cpp, so you can check it here, command line arg.exe. so now if I try to execute that command line arg, so exe file you don't need to provide the .exe, you can if you want. Now we are giving hello space world. Okay, so the program name itself will go as the first text. Okay, second hello will go as the second one, and world will go as the third one. So in the code, if we look back, that is the argv argument vector sub 0 basically represent the program name, argument vector sub 1 represent the input hello, and argument vector sub 2 represent the input world. Okay, so therefore if we want to print hello world, now this will print hello world. Okay, so our code tells, we run the loop from 1 because we don't want to print the program name, we just want to print hello world, so it starts from 1, and the value of the counter is 3 because 3 arguments, so index is 0 1 2, so the index from 1 and 2, so it will print hello world. Okay, so if I press enter, now it is printing hello world. Okay, so having command line argument is not a new thing in C++, so therefore the number 3 are also not a difference. Okay, but in Java we don't need to provide the counter. Okay, we don't need to tell how many strings are there. Okay, and Java it is an array of string, but the notion of array is little bit different in Java, so let me try to explain that little bit. So suppose you have a function called doSum, let's say void doSum, and it takes an integer parameter, let's say integer array, so let's say int a, and suppose we provide the size, and that is the function. Okay, now when we call this from the caller function, okay, so let's say main is the caller function or any other function, so when we call the doSum, we need to have an integer array, so let's say int arr of 10, okay, or whatever the size, okay, let's say 10, and suppose we have the input. Okay, so we have the input here. Okay, now if we want to call the doSum, so doSum we send ARR comma 10. Okay, so if we look into the parameter list, the first one is the A, which is a reference to an integer array. Okay, so here the subscript operator comes after the parameter name. Okay, and the type of the element is integer. But on the other hand, in Java, the the angle bracket, that is the subscript operator, actually comes with the type string. Now why it is like that? Because in Java, every array we declare is an object instance. Okay, so therefore if we have a class for example, if we have a class, any class, let's say class A, okay, in C++ or any language. So if we want to declare an object, now let's say we want to declare instances for A, so we can say A, let's say object 1. Okay, now you see object 1 looks like a variable name, okay, which is the class variable name. We call them object instance, and A is the type. So when we say that an array in Java is an object, that means args argument string, it can have any name, basically an object instance name, okay, object name, and the bracket is part of the class name. Okay, so string with angle brackets together represent the type of the object. Okay, so that's implicit class name. We don't need to, neither we can declare this class, define this class. Whenever we have a valid type, we can declare an array, and whenever we declare an array of any valid type, that array class becomes an implicit type. Okay, and in our case args is an object name, and that is why if we put the bracket this side, then args looks like an array of objects, which is not. And also the type of the array is not string, type of the object is not string, sorry, the type of the object args is the string array, implicit array. Okay, that is why the bracket is that side. Okay, so I'll talk about or cover more on this in a future video on Java array, but as of now we understand that is why it looks like that. And why we don't need to give the number of elements, because since it's a class, so we can actually say args dot length. In that case, length is a field, okay, associated with this class. Okay, so that is why. Okay, so let's continue. So therefore we can say that number 3, it may look different in this particular example, but essentially both main can take parameters. Okay, the fourth difference that I'm coming here, that is basically the line which is printing the hello world. They look completely different. Are they really different? If they are, then how much they differ? I'm going to cover this as the last part, but before that let me cover the difference 5 and 6. Okay, now as we know, the by default any member function or method in a class is private. Okay, so to make it available to be called from outside the class, we have to declare it as a public. Very simple. For a global function, it is global, so any other function within the program scope actually can call the main. So therefore it was not necessary to declare it as a public, because it's not a member function of any class. Yeah, so that's a difference, but essentially adding the public actually allowing this main to be called within the context which is outside of the class. That makes sense. Okay, now I will come to that, but before that let me cover the static part. Okay, Now the function itself in Java, it says it is static. Okay, so we understood void, we understood public, we also know that both main can have arguments. Okay, no problem, but only unknown thing here is static. Okay, now what is static? Now if you look at the class either in C++ or Java, by the way, if you are new to the class concept, there's a video in this channel. You can see the card somewhere here, and you can watch that video to get better understanding about class. Okay, if you are new to the concept of class. Anyway, so in class, whenever we declare a field, let's say in student class, we declare a field called ID, student ID. So let's say class student. Okay, and here we have a field called let's say int ID. Okay, now that is your class. Okay, so we can also do the same thing for C++ too. So let's say, okay, so now this ID is a private field. Now whether the field is private or public, that really doesn't matter. What matter is every instance of the student class will have its own memory to store their ID. Okay, so so for example, if I say let's say that is the student class. Okay, now to keep things short, let's say if I declare a student instances, multiple instances, student let's say John and Rocky. So John and Rocky are two student instance. Okay, and once we have the memory allocated for John and instance, so John equal to new student. Okay, now sorry, and Rocky also new student. Okay, so we have created instances for both student object. Now if I say John dot Rocky, now if I say John dot ID, so John dot ID, though I cannot say that because ID is private, but for the sake of discussion, it can have a different value. Okay, so let's say 1 2 3, and Rocky also can have its own value, Rocky dot ID. Okay, so let's say 1 2 4. So now see the ID, the field ID, it's an instance level field. It means every instance, in our case John and Rocky, have their own memory to store that integer ID. Okay, so if we want to access a non-static member, in this case non-static field, we have to use a instance, okay, as the client. Okay, so from which instance this ID is coming, from John or from Rocky? So without the instance, okay, we actually cannot use the non-static field. Same thing for a method. Okay, so suppose you have a method, let's say public void do sum. I'm writing the Java code. I can also write the equivalent C++ code, but that will be redundant to explain the same concept. Okay, so you have some code here. Now if I want to call the do sum, again I have to since it is public, I can call that, so I have to use John dot do sum. do sum, or I have to call the do sum specifying Rocky as the client. Okay. So now for the first call, do sum has access to the instance level fields of John, and for the second call, do sum have access to the instance level field from Rocky, and that is why the method or member function can potentially access the private fields, non-static fields. So you have to tell that from which instance the fields will come, and that is why you have to specify an instance as a client for that call. Okay. So that is all about non-static. So if we don't specify anything about the field or method, they are non-static. Okay. Now if our main is non-static, then we have to technically specify a client. Okay. So of the, because it is a method of main class, so like we declared and we created an instance John, then only we could call the do sum John dot do sum. Similarly, we have to create an instance of main class, let's say main class obj equal to new main class, then only we could call obj dot main. But the problem is we are not creating an instance in our program, because main is the starting point of the execution, and which will be invoked from outside the main class, okay, by the Java runtime environment, from the Java runtime environment. So therefore the main function actually cannot be called by instance, because no instance of main class will be created in the Java runtime environment, and so therefore it will not be possible to call it using specifying a client. Okay. So what is the solution? The solution is declaring if you declare a field as a static, or a method as a static, then the static field does not belong to any instance. Okay. For example, in student class, suppose if we have a string, okay, so string uniname, okay, so uniname, now let's say some name of some university XYZ. Now you see that uniname, same uniname will be copied into many student instances. Okay, so John also will have a copy of the uniname XYZ. Rocky also will have a string uniname. So same value will be stored inside every instance. Okay, so that's a wastage of space. So ID, name, CGPA, of course, they are different for different students, so they need their own storage. But for university name, we can actually have a common copy. So instead of creating so many memory space for each of the students for the string uniname, we can actually create one single string, okay, and we call that class level field. Okay, so that will be shared by every instance. Okay, so every instance John and Rocky will have a reference to a single copy of the uniname. Okay, now each John and Rocky has their own ID, own memory to store ID, but they don't have any memory to store uniname, because they don't store uniname separately, provided we declare it as a static. Okay, so if you declare a field as a static, that means it's not instance level field. Okay, it's a class level field, so which has some global sort of, okay, so it's not associated with any instance. Okay, so therefore if you declare a method static, that method also don't require any instance as a client, because static method can access only static fields. Okay, so since static method will never ever be allowed to access a non-static field like ID, name, CGPA for the student class, so therefore a static method don't need any instance to be specified as client. Okay, because it's not going to access any it cannot access any non-static field, okay, like ID name. So therefore we don't need to tell John dot now suppose the do sum is static, public static void do sum. Now we don't need John and Rocky to call do sum. Okay, in fact now we cannot call do sum with John and Rocky. So therefore, to call a static method we don't need any instance. Okay, so we can call it using the, actually we have to call it using the class name, so which is student, okay, dot do sum. Okay, because now do sum is a static method. So therefore, you see now the caller, in this case main is the caller, need not to have an instance of student to call do sum, right? Now but to call a non-static method, for example populate, so public void populate. Okay, so in this case which will populate the fields of student class. Now we have to specify an instance as a client. Okay, so without the instance John or Rocky or any other valid instance, we cannot call populate. Okay, okay, but to call do sum we don't need any instance. Okay, because do sum is a static method. Okay, so therefore a static method can be called from outside without having any instance. Okay, so main function will be called from Java runtime environment, and it is out of the scope to declare and create an instance of the class where the main method belongs, and that is why main method has to be static. Okay, so that it can be called without declaring and instantiating an object. Okay, and then specifying it as a client in the Java runtime environment. Okay, that's out of the scope. Okay, so that is why the main function has to be static. Okay, so now if I come back, okay, so static versus non-static, that makes sense. Okay, but you can say who calls the main function in C++. Okay, so that works a little bit different way. That actually when the linker actually builds the C++ program, it actually writes the address of the main function in the execute address, okay, which is used by the operating system to get the location of the main function, and it starts executing from there. Okay, now the last part, do they use the same tool to display the text? Now here if we look at C++, it's telling cout, then the left shift arrow. From the context of cout we call it extraction operator hello world. Okay, so apparently we don't see any, but here any function or method involvement. Okay, but here in Java we clearly see there is a method print line is called. Okay, but if we analyze this particular line we will see that there are actually method. Okay, so if I analyze this particular code, this is basically calls this is called operator overloading. So if you are familiar with operator overloading, you already know what it means. If not, then there is another video on operator overloading, you can check it out in this channel. Okay, okay, so this actually nothing but cout dot operator. This is the method name. Okay, so this is the operator method, so therefore parenthesis. Okay, and the parameter is hello world. Okay, so just if I just exclude that end line part for the sake of simplicity, now you see this hello world is printed by calling a method, the operator method. Okay, so in that sense they are actually similar. Okay, here a method is called and the text is the, or whatever we want to print, display on the screen is the parameter. Here also a method is called. The method name can differ, that's okay, but the mechanism is similar, okay? So method is called. Now here cout is the client, an instance of OSTream class, so therefore it has to be a non-static method of OSTream class, okay? So if I try to show you, let's say the OSTream class. So in OSTream class, if I show you that, you will see this operator method is already overloaded, okay? So there are many version of this operator method, okay? So that is the method name. So there is also a video on operator, function or method overloading in the channel. You can also watch that. So you see it actually overloaded for all known types, okay? So therefore when you say cout integer, this version gets executed. When you say cout a float value variable, this version gets executed, okay, and so on. So that is basically calling the function or method, whatever we can say. So here also we are calling the print line method. Now this operator method is a method of the OSTream class. We have seen this print line method is a method of some class where out is the instance, okay? So basically it is the instance of the print stream class. So if I try to show you print stream class, so as you can see print stream class print stream, and if we see the field summary, you can see that method summary, you can see that the print method is overloaded for all known types, okay? The print line is also overloaded for all known types. Print line means print with end of line, okay? So which is equivalent of giving endl in C++, okay? So that's why it works. So it's effectively the mechanism is same, okay? So here in C++, we are calling the member function of the OSTream class. Here we are calling the member function or method of print stream class, okay? Now why that system dot comes here, okay? Now in C++ we use cout, but we never declared cout. Now think of the scenario, you can declare your own OSTream object. So OSTream, let's say my out, and can we write my out arrow x if x is an integer, let's say int x some value. Now this should work because cout works. Now if I use cout x, it perfectly works, but if I use my out x, it doesn't work, it will give error. The reason is, but both of them are instance of OSTream class. Now this is coming from the namespace std, this we have declared. Then if the std namespace instance works, then why our instance doesn't work? Because the declaration of instance is not enough. You have to associate the instance with the source of the stream, in case of iStream, scene, or destination of the stream. Now the destination of the stream can be screen, it can be printer, it can be network. Therefore we need to associate that. We have to establish the device with the stream. Now that establishment is already done in the namespace, and that is why we don't need to declare. And if we use that particular object from namespace, it is already the link is established with the screen, but it is not for us. So we have to write the code before we use this to actually establish a link of this stream with the screen or with the printer, then only it will work, okay? Now similarly we have to establish the link with the out with the print stream object instance with the screen. Now when we use a special object cout instead of my out, we don't need to do that. Similarly, when we use a special object out which is a field of system class, then we don't need to do that. So let me show you before I finish the video. So let's say the system class. So if you look at the system class, you will see that system class, if we look at the field summary, there is a field called out, which is a whose type is print stream. Okay, so the like we are getting the cout or scene from the namespace std in C++. Similarly, we are getting the in and out from the class system. Okay, now we could declare our own print stream and we could try to use that, but then again we had to establish link the stream with the device screen. Okay, but the constructor of system class actually takes care of that, so therefore we don't need to make the association of the stream which is out with the physical device. Okay, so therefore if we look at the number 4, that is tool to display is different. It may appear that they are totally different, but essentially their mechanism is same. Okay, so that's it for the day. If you like the video, please give a thumbs up and consider subscribing, and thanks for watching. See you in the next video.